There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega-earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia subduction zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
An hour after people disappear, most urban areas will be left empty and quiet. Perhaps the sound of wind, falling leaves, or other natural sounds previously drowned out by city noise and traffic will be heard. The subways of many cities are protected from groundwater by a system of pumps. If there are no people to monitor such systems, most subways will flood within 36 hours. Due to malfunctions, sewage treatment plants will stop working, leading to pollution of rivers and lakes with wastewater. The water pipes in Detroit will become unusable, leading to the flooding of the city. Food in refrigerators will spoil. Raccoons and wolves will inhabit abandoned human homes. Major airports will be covered in rust and overgrown with ivy. Cruise ships in Alaska will sink under the weight of ice that accumulates on them. Lions from the San Diego Zoo will gradually escape, emboldened by the power outage of the electric fence around their enclosures. More and more black cats will appear on the streets of Rome and the Vatican. Rats and mice will consume all edible reserves and leave the cities. plants will begin to grow in cracks in streets, highways, sidewalks, and buildings. More and more animals will notice the absence of people and flock to the cities. International Space Station will gradually decrease. Since no one will correct its orbit, the station will eventually fall to Earth and burn up. Along with it, digitized samples of human DNA will perish. A large part of the city's territory will be covered with a vegetation of lianas, grasses, and tree seedlings. The Red Square in Moscow will have a layer of soil and thick grasses growing, making the square completely green. Despite high levels of radiation, animal populations are increasing in abandoned areas. Plants have grown in many houses and buildings. Seawater will flood cities that were once drained by artificial drainage systems, such as London and Amsterdam. Satellites will begin to fall to Earth. Since no one maintained their speed of movement, they slowly approached Earth and eventually fell to the planet's surface. Wolves now roam freely around the Brandenburg Gate in Berlin, and wild boars will be seen in Paris. Human speech will be preserved in rare words that parrots have memorized during their years of living with humans. Snakes will not only reproduce at incredible rates, but also grow much larger in size. Their main prey will be rodents that have multiplied in the first years after humans disappeared. Many human-made structures will collapse within 100 years, primarily those with a large number of steel elements. Fruit Christmas cakes, thanks to their alcohol coating, will not only retain their appearance but also freshness. Most buildings will be overtaken by plants and animals, and the city will resemble more of a wild nature landscape. The period of nuclear fuel decay will come to an end, and as a result, dead zones around the ruins of nuclear power plants will once again become habitable. The last parrots that spoke human language may go extinct since they memorized human speech, but it is simply not necessary for their survival in the wild. All modern carriers of information that preserve human culture, laser discs, photographic film, paper, and the like, will turn to dust. Rebar inside concrete buildings, which are more durable than steel ones, will expand 3 times due to rust, causing the destruction of concrete structures. Most modern cities will be covered by a green blanket, and collapsed skyscrapers and buildings will become new hills. Manhattan will return to its former state before human settlement, with numerous streams and lakes. There will be almost no evidence of the existence of human civilization. Only powerful stone buildings that rely solely on the force of gravity will survive, such as Notre Dame de Paris. Of the products that existed during human civilization, only honey, especially in clay pots, and oil in wooden barrels, will be well preserved. Only a few stone structures will survive, including the pyramids in Giza and the Sphinx, almost entirely buried in the sands of the desert, and fragments of the Great Wall of China. By this time, a new ice age will begin on Earth. It is expected that the KEO satellite will enter the atmosphere by this time. Various pieces of space debris will collide with it during its descent, but this will not destroy the satellite. Eventually, it will fall into the waters of the world ocean. Remnants of spacecraft and satellite debris will float through space as the only reminder of human civilization.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.
On September 16th of 2023, without warning, the Earth began to hum. A low, strange vibration reverberated through the crust. This set off seismic alarms all across the globe. For 9 days straight, the planet was pulsing with this horrifying rhythm, and scientists had no idea what was going on. Meanwhile, the total disaster was happening in Greenland. It wasn't an earthquake. They knew that much. They could tell it by the rhythm. Since we all live on giant tectonic plates, they constantly move and slide on magma like icebergs on water. Sometimes as they move, they can rub against each other or collide or break. In any case, all this causes an incredible release of energy that sends shockwaves through the ground. That's when we feel the ground literally shaking, and it's what we call an earthquake. These vibrations we feel are called seismic waves. Seismometers pick them up as pings or rumbles. In a typical earthquake, they create a bunch of different frequencies. It's a crazy chaotic mix of low and high frequencies, like smashing every piano key. What was weird about the Greenland event is that the signals weren't like that at all. It was a steady, single-frequency vibration, as if some ancient machine was stirring beneath the earth. It's like one piano key being struck over and over, creating a doom-like, repetitive sound. Turns out, what they were hearing wasn't the noise of tectonic plates going wild. It was a phenomenon seismologists had never seen before. The days passed, and the mysterious noise just kept going. The vibrations repeated every 90 seconds, echoing around the world. The hunt for answers was growing more desperate. Seismologists had no idea what they were dealing with. They had to gather a huge international team of 68 people from 15 countries. All these scientists were gathering seismic data, satellite images, and doing some advanced math for several days, until they finally realized who the culprit was. Water. It all happened in a remote, desolate region of East Greenland. This place is full of fjords, narrow inlets of the sea between high cliffs, kinda like deep water-filled valleys surrounded by towering rocky sides. In this area, surrounded by jagged peaks and icy waters, the air was still. The landscape seemingly frozen in time. Nothing here changed much for years. Until one day. A colossal landslide has unfolded in the Dixon Fjord. One of those steep mountainsides towering over the fjord at almost 4,000 feet high collapsed in a massive landslide. Picture a huge chunk of this mountain crumbling and crashing down into the fjord below. This sent a deluge of rock and ice crashing into the water. The impact was just apocalyptic, 882 million cubic feet of debris. That's enough ice and rock to fill 10,000 Olympic-sized swimming pools, or 10 Great Pyramids of Giza. And all this nightmare hurled into the water with such force that it kick-started a tsunami about 360 feet high, taller than the Statue of Liberty, into the air. What's crazy is that this incredibly powerful wave was trapped in the fjord by narrow cliffs, unable to escape. It's like water sloshing in a closed bathtub. For 9 days, the mega tsunami continued to churn through it. That's why we heard this endless hum. It was a rhythmic back and forth of the water slamming against the walls. The shock waves were rippling deep into Earth's crust, vibrations so strong that they were picked up by seismometers around the globe. This was a phenomenon so rare, so unprecedented, that it left scientists stunned. It turned out to be a perfect storm of elements. A glacier, weakened by years of warming, could no longer bear the weight of the mountain above. This collapse was inevitable, and the chaos literally shook the Earth to its core. And people often hang out in this area with cruise ships passing by. We're lucky that no lives were lost in the disaster. It was a close call though. A tourist ship stranded in the area just 2 days before narrowly escaped the tsunami's reach by pure luck. But it doesn't mean there were no losses. The waves destroyed a nearby Inuit site, which was there untouched for over 200 years. They also swept away the huts at a research station that were about 43 miles away. The vibrations traveled from Greenland to the South Pole in less than an hour. That just shows how dangerous events like this can be. And this isn't the only place where such catastrophes are happening. In the beautiful California community of Rancho Palos Verdes, the ground is shifting so quickly that it's tearing homes apart. The land there has always been kinda unstable. It has some unique geology. It's built on soft, clay-rich soil and sits on a geological fault line, which makes it prone to landslides. This means that this land is prone to slow, natural shifting over many years, even when no crazy weather is happening. It's been like this for decades, but usually it's slow and pretty manageable, like about a foot a year. Imagine a tree that you played with as a kid moving 20 feet to the left as you grow up. For decades, residents adapted. They built their homes on adjustable beams. This helped the houses to move with the land, and that strategy worked well until now. Recently, things have been getting much worse in the community. Now, the land is moving by a foot in a single week. That would be like if the same tree moved almost 960 feet since you were a child. The past 2 years have also caused some heavy rains, and the weather has been getting worse. This increased water content in the soil. The land became heavier and more prone to rapid movement. Now, this once idyllic seaside escape turned into a disaster zone. Cracks have appeared in closets, gardens, and roads, growing larger with each passing day. Streets that were once smooth are now buckled and twisted, with roads turning into a crazy theme park. Houses that once stood firm are being ripped from their foundations, some of them split in half. One of the houses had its front door 8 feet off the ground. Entire neighborhoods have been plunged into chaos. Utility companies had to switch off gas and electricity indefinitely to prevent potential disasters. The hardest hit is the coastal neighborhood of Portuguese Bend, where residents are living on the edge, literally. It always had amazing ocean views and cool sea breezes, with horses and peacocks still wandering the tree-lined streets. But now, it's like an earthquake hit. Only this time, the earth isn't stopping. For many, this place feels like paradise, if only the land would stop shifting beneath their feet. So the locals don't give up. Some of them had to leave, but many are determined to stay and fight, despite the destruction. But they still have to pour in hundreds of thousands of dollars to save their properties. People have installed generators to keep the lights on and set up sewer systems and pumps to drain the groundwater causing the landslides. Some say that the only way for these neighborhoods to survive might be to go completely off-grid, installing power walls to store energy and stuff like that. People are trying their best to run the sewer system off generators. They hope that they could get rid of this water in the soil that's causing these hellish landslides in the first place. They're determined to fight, but they will need help and support from the government to fight this disaster. Landslides are actually more common across the US than many might think. And new maps and data show that tons of people in the country might be in danger. Scientists managed to create the first very detailed, very cool map that shows where these landslides might happen, county by county. It's based on a lot of data and the history of 1 million previous landslides. They say that nearly 40% of the United States is at risk of experiencing landslide activity, which could lead to some insane catastrophes in certain areas. Luckily, now both residents and engineers can keep this in mind. But all this shows how vulnerable we are to natural disasters and how we should always stay alerted.
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail – communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras – red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed. and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle, and not just local eruptions.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Chilean University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. but roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
Imagine there is a huge crevice right under your house. What would you do? Probably pick up your belongings and evacuate the structure. This is what happened to one Kenyan back in 2018. A massive crevice formed almost overnight under his home. The man escaped to safety, but the event revealed a deeper issue, much deeper than most people thought. The crevice appeared after a month of heavy rainfall. This part of the country, west of the Kenyan capital of Nairobi, sits in a seismically active region. The massive hole in the ground was covered with ash from a nearby dormant volcano. The crevice in the ground ran for miles, and it was 65 feet wide in some places. It was as deep as the Hollywood sign is tall. The gaping hole damaged a vital local road. People soon dubbed it the Grand Canyon. But this is no laughing matter. The same thing happened in 2023. Kenya's highway authority had to close the busy road for repairs once again. Preliminary reports showed that heavy rains were the likeliest cause. The rupture itself is part of the Great Rift Valley. It extends from Jordan in the north to Mozambique in eastern Africa. Its total length is nearly 1.5 times the distance from New York to Los Angeles. Rift valleys are located all over the planet. They're lowland places where tectonic plates move apart or rift. These are huge slabs of rock in Earth's outermost layer. They rest on molten rock underneath, which makes them unstable. Tectonic plates are constantly on the move. They can bump into each other, or one plate can go under another. This can occur both on land and at the bottom of the ocean. Continental rifts are less frequent than the ones we find underwater. The East African Rift is one of 4 major ones. The nearby Arabian Plate has been on the move for the last 30 million years. When it separated from the African mainland, it created the Red Sea and the Gulf of Aden. When you look at the physical map of Africa, it looks like one contiguous landmass. But when you dig deeper, quite literally, you realize it rests on 2 tectonic plates. The Nubian one carries most of the continent. The smaller Somali plate holds the Horn of Africa. The crevice in Kenya appeared in the rift valley between these 2 plates. That's because they're moving away from each other. The rift is growing larger, which means that one day the African continent will split into two. The rifting process is a slow one. The present rate is just 1/4 of an inch every year. Scientists estimate that the split will occur in 5 to 10 million years. Some experts place this event 50 million years into the future. The end result will be two African subcontinents. They will be separated by a body of water that will become our planet's 6th ocean. This also means that 5 now landlocked countries will get access to the sea. When they get a coastline, the countries could build harbors to trade with the rest of the world. 3 other countries, including Kenya, would find themselves on 2 continents. The future split of Africa into 2 parts might sound dramatic at first, but it wouldn't be unnatural. This is the first time, after hundreds of millions of years, that the shape of Earth would change so much. The last time this happened was during the Jurassic period. If you're now thinking of Steven Spielberg's 1993 blockbuster movie, you're right. The world of dinosaurs had a different shape than the one we're familiar with today. There was a supercontinent called Gondwana. It included today's South America, Antarctica, India, Africa, Arabia, Madagascar, and Australia. Then, around 180 million years ago, things started to change. Earth was starting to take its familiar shape. The Indian subcontinent collided with the Asian mainland. The event gave rise to the Himalayan mountain range. These are the highest mountains in the world, with 30 peaks over 24,000 feet in altitude. This process is far from over. The Himalayas are still growing in height. On the other side of Gondwana, Africa and South America first separated together. But they weren't meant to last long. 40 million years later, South America started drifting away from Africa. This created the South Atlantic Ocean. The evidence of this ancient continental drift is obvious to this day. If you look at the map of South America, you'll notice a bulge in its eastern part. That's the modern country of Brazil. On the other side of the Atlantic, Africa has a huge inland curve on its western side. The two act as pieces of a giant jigsaw puzzle. They roughly fit into one another. European scientists noticed this as early as the 17th century. Further research confirmed the theory that South America and Africa once belonged to the same landmass. This is only one part of the story. At the beginning of the 20th century, a German scientist came up with the theory of continental drift. He believed that all of Earth's continents were once part of a supercontinent called Pangaea. The name comes from Greek, and it means all of the Earth. Makes sense, doesn't it? It was surrounded by the oceanic ancestor of the Pacific Ocean. Some 200 million years ago, this gigantic landmass was home to many animal and plant species. Thanks to them, scientists could piece together what our planet used to look like. For example, Mesosaurus was a giant freshwater reptile that existed during the Cretaceous period. Paleontologists found its fossils in only 2 places, Africa and South America. The animal lived in fresh water, so there was no way it could have swam in the Atlantic Ocean. This pointed to the fact that it lived in a single habitat, rich in rivers and lakes. This would have been possible in only one scenario. The 2 continents that are now miles apart were once a single piece of land. Pangaea wasn't the only supercontinent in Earth's history. Continents came together and drifted apart several times throughout our planet's past. Researchers know of at least 3 times this happened. Pannonia formed 600 million years ago. Rodinia was an even older supercontinent. It existed 1 billion years ago. The driving force behind all these changes was tectonic activity. Plates deep beneath our feet have the ability to create new land and oceans. This is what's happening in East Africa right now. This activity is most evident at the bottom of the sea. Molten rock rises from deep within the Earth to create new seafloor. The process is called seafloor spreading. It happens along underwater mountains called ridges. One example is the Mid-Atlantic Ridge. I think you can fairly accurately guess its location. Over time, the seafloor grows wider here. This has an effect on the continents on both sides of the ridge. Seafloor spreading causes continents to move away from each other. Right now, North America is moving away from Europe at a rate of 1 inch per year. This doesn't seem like much, but give it 50 million years and the Americas are gonna bump into the western part of Asia. The two landmasses will form a new supercontinent. Geologists from Yale University have a name for this land: Amasia. Talk about rushing before the ore. They ran a series of computer simulations to see what Earth would look like millions of years from now. The new continent is likely going to form somewhere around the North Pole. But don't go shopping for winter clothes just yet. The time frame for this event might extend to 200 million years into the future.
Now, if you could get into a time machine and travel back to 1969, you'd see something spectacular. What you're looking at isn't some random desert. It's one of the most powerful waterfalls, completely dry. In the summer and fall of 1969, the American side of Niagara Falls stayed without water. It lasted 6 months. Researchers wanted to study the rock face of the falls. They were afraid it was going to become too unstable because of erosion. Erosion is the process when natural forces, such as water and wind, wear away earthen materials. For example, if you see glacial ice become muddy, it means erosion is happening. 3 waterfalls that cross the international border between Canada and the United States together make something we know as the magnificent Niagara Falls. The 3 waterfalls are the Horseshoe Falls, the American Falls, and the Bridal Veil Falls, in order from largest to smallest. The American Falls are fully on the American side, while the Horseshoe Falls are primarily on the Canadian side, divided by Goat Island. The Bridal Veil Falls, the smallest of them all, are on the American side, but separated from the others by Luna Island. Don't America and Canada have a cool natural border? Many didn't believe we could actually go against wild nature and stop such insane amounts of water from flowing. But we did it. It took a 600-foot dam across the enormous Niagara River to really shut down these astonishing falls. This means they had to divert 60,000 gallons of water every second so that the remaining flow traveled over the biggest Horseshoe Falls, the ones that are completely on the Canadian side of the border. Over 27,000 tons of rock were used to construct that dam, and more than 1,000 trucks carried that rock back in the hot summer of '69. On June 12th, the American Falls stopped after their continuous flow for more than 12,000 years. So the Horseshoe Falls then took the extra flow and absorbed it so that research could be done. But the locals were still worried. They knew it wasn't possible to control such amounts of water. They were afraid the water might take a different route and cause a catastrophic flood. They were worried that tourists wouldn't come anymore if teams didn't manage to make the waterfall flow again the way it used to. But tourists kept coming even that summer, and they got a unique chance to see something no one had ever seen before or after. During that period, there was even a temporary walkway built only 20 feet away from the edge of the now dry falls. It helped workers to clean the bottom of what used to be a river, so tourists could go there and explore the wild landscape of the falls that was usually under the water, hostile, and not accessible to visitors at all. As they were exploring the dried bottom of the falls, researchers stumbled upon millions of different coins people had thrown in the water over decades, maybe to make a wish or for some other purpose. Wow, a Niagara Falls piggy bank! Well, they removed most of those coins. I wonder who got them. But in the past couple of decades, more and more tourists have been coming here. Imagine all the things they could find now. More coins, of course, but also lost cameras, errant drones, cell phones, and other things careless visitors could accidentally drop in the waterfalls. The idea of removing all the water and turning Niagara Falls into a desert proved to be possible, but it may need to be done again. In 2020, the media reported that 2 pedestrian bridges in Niagara Falls needed to be either replaced or repaired. No wonder, since they're almost 120 years old. These bridges are located above the rapids. Experts discuss whether they should divert the water once again or not. People talk about Niagara Falls a lot, and some believe they're among the tallest waterfalls in the world. But the truth is, they're not. They're famous, precious, and breathtaking. But when it comes to height, there are nearly 500 other waterfalls across the globe that are taller than Niagara. Let's take Angel Falls in Venezuela, for example. They're more than 3,000 feet tall. But what makes Niagara Falls so special, among other waterfalls, is the amount of water that flows over them. Very high waterfalls don't usually have great amounts of water. The combination of all those huge amounts of water and the height is what makes Niagara Falls so breathtaking. Also, they might be some of the fastest-moving waterfalls on our planet. The Niagara River appeared after the last ice age, together with the whole Great Lakes basin. The Niagara River is part of it. 18,000 years ago, I wasn't around then, this awesome waterfall didn't exist. Ice sheets covered the area of southern Ontario. They were 1 to 2 miles thick. As the ice sheets were moving southward, they created the basin of the Great Lakes. Then they melted, releasing enormous amounts of water into the basins. Generally, the water we drink is fossil water. Only 1% of it renews through the year, with the remaining 99% coming from ice sheets. The Niagara Peninsula hasn't been beneath the ice for nearly 12,500 years. As the ice melted, the resulting water started to flow down through what later turned into Niagara River, Lake Erie, and Lake Ontario. It took a lot of time, but the water eventually eroded cliffs and formed these spectacular falls. Now, you might have noticed that the Niagara River is amazingly green. This specific color tells us how powerful the water is when it comes to erosion. Every minute, Niagara Falls spews over 60 tons of dissolved minerals. All that, together with dissolved salt and finely ground rock, makes the color so magnificent. People who live in the United States and Canada, or more precisely, over 1 million people who have access to the area, use the waters of Niagara River for different purposes. For example, fishing, getting drinking water, doing recreational activities, including swimming, boating, and birdwatching, producing hydroelectric power, and so much more. Now, the first hydroelectric generating station in the world was built at the end of the 19th century, and it was right next to the falls. Pretty soon it started paying off because people were getting electricity from it. But this electricity could travel only 300 feet, so something needed to be improved there. Nikola Tesla was the one who took up the challenge and made the necessary changes. He discovered that electricity could travel long distances if an alternating current was used. Today, several Niagara Falls power plants provide over 2 million kilowatts of power. Okay, I'll tell you another interesting thing. 1969 wasn't the only time when Niagara Falls stopped. Back in 1848, the water didn't flow over the falls for up to 40 hours. Now, the falls were already very popular among tourists and a useful source of energy for local people, so no wonder they freaked out. Nature was to blame this time. Ice blocked the source of the Niagara River. An American farmer was the first one to notice it. It was March 29th, and he went for a walk right before midnight. Soon, he realized he couldn't hear the powerful roar of the falls. He quickly went to the edge of the river and stood there in shock. There was hardly any water. Factories and mills had to shut down because they depended on that water. Turtles were just wandering around. Fish didn't survive. Some people took a walk on the river bottom, taking little things they could find there as souvenirs. But 2 days later, on March 31st, people heard a distant rumbling coming from upriver. It was getting nearer and louder until a wall of water appeared in front of their eyes. And one of the world's greatest attractions that millions of tourists visit every year was back in business again. Magnificent and, in the end, invincible. As it should be. Ah, Phoenix. This sizzling gem in the Sonoran Desert isn't just another American city. It's more like a giant oven where you can throw a party, as long as you don't forget the ice. Seriously, if you find yourself here in the summer, brace yourself for some serious heat. We're talking about temperatures that regularly pass 100 degrees. And in 2024, Phoenix hit 110 degrees 55 times during the summer, tying the record set just the year before. Now, I get it if you're not a fan of hot weather, but apparently a lot of people love living in a sauna. Phoenix ranks as the 5th largest city in the United States, and it is the capital and most populous city in Arizona, with 1.7 million residents as of 2024. And if we're talking about the metropolitan area, also known as the Valley of the Sun, the population is almost 5 million. Yet, good luck finding someone actually born here. Out of every 4 Phoenix residents, 3 were born somewhere else. Believe it or not, Phoenix wasn't always this bustling, crowded place. It became one. A few decades ago, it was just a sleepy little dot on the map. Back in the 1940s, the population was around 65,000. It wasn't even close to cracking the top 100 list of the largest U.S. cities. Now, at that time, Phoenix was mostly an agricultural hub, and its economy revolved around what they called the 5 C's: cotton, citrus, cattle, climate, and copper. But things really started to change in the 1950s thanks to one life-changing invention. Drumroll please? The air conditioner. Actually, it was the portable version that came out in 1945, created by an American inventor named Robert Sherman. Phoenix residents owe a lot to Robert for making life bearable during scorching summers. Before AC, people in Phoenix would literally move their beds outside and build sleeping porches. They'd protect that kind of outdoorsy space with light curtains or some kind of net to keep the dust and bugs out. Fun. Anyway, the point is that the air conditioner played a big part in making Phoenix an easier place to live. Since the 1940s, this city in Arizona has transformed from a dusty little town into a sprawling urban jungle, and it's still one of the top 10 fastest-growing metro areas in the U.S. The best part is, it looks like that won't change anytime soon, since this 519-square-mile metropolis is surrounded by rolling desert, with plenty of room to keep growing as far as the eye can see. So, who's dropping everything to move to Phoenix? Well, Californians are the city's biggest fans. According to a recent survey, a third of all new renters moving to Phoenix come from Los Angeles. Okay, that survey might not be the most reliable since it only applies to the source's clients, but it does line up with U.S. Census Bureau data from 2019, which says that 70,000 Californians moved to Arizona in the previous year. The connection between Phoenix and LA is so strong that some people even call Phoenix the next LA. You've got to give Phoenix credit for capitalizing on its proximity to Southern California. The city offers lower taxes, fewer regulations, and lower costs of living, which makes it a magnet for businesses, especially in high-tech and service industries. So, in the 90s, Phoenix was considered a non-stop generator of jobs. In the last few years, we've seen the number of jobs only go up, and the unemployment rate has dropped by nearly half, going from 6.3 in January 2014 to 3.4 in the same month in 2024. Now, when it comes to big city problems, you can't avoid talking about traffic. But here's another reason why Phoenix is a dream city. It doesn't even come close to the traffic nightmares you find in places like LA. Estimates show that people in Los Angeles waste about 119 hours a year just sitting in traffic. But in Phoenix, it's more like 61 hours. Huge difference, huh? And let's not even start talking about the money people waste just sitting in traffic. In LA, drivers burn through about $2,440 worth of gas per year. In Phoenix, they waste 25 gallons of fuel, which ends up costing about $952. Yeah, that's still a lot of cash, but compared to LA, come on, that's a steal. Phoenix being okay in terms of traffic might have a lot to do with how the city was designed. Just take a look at a map of Phoenix. You'll notice it looks like someone took a ruler and drew perfectly straight lines for the roads. That's because the city was laid out in a grid system. This setup makes it so much easier to get around, especially compared to cities full of confusing twists, U-turns, and one-way streets. It just simplifies things, whether you're a local or a tourist. Plus, Phoenix has nice wide streets. Most cities have one major road and a bunch of narrow streets that just can't handle heavy traffic. But Phoenix has wide roads everywhere. So, when the freeways get jammed, you can just hop onto a parallel street and still get to work without stressing out too much. When you look at all the job opportunities and the relatively smooth traffic, it's no wonder people are willing to put up with the heat and move to Phoenix. But don't get it twisted, the heat is no joke. It is really, really hot and sunny out there. We're talking about 300 days of sunshine on average, or about 85% daylight hours per year. But once again, Phoenix has made the best of it. And all that constant sunshine has turned Phoenix into one of the top solar energy cities in the country. Now, you may be wondering, a city in the middle of the desert with barely any rain, do they actually have enough water? Well, they do. Phoenix has its water situation pretty well sorted out, thanks to multiple sources. I mean, they don't rely on rain alone, which is a good thing because, desert life. Most of their water comes from way up north and east of the valley, where snow melts off the mountains and flows into giant reservoirs, storing it up for those dry years. But most of Phoenix's water comes from the Salt River Project, which brings water through canals and pipelines from the Salt and Verde rivers. Then there is the Central Arizona Project, which transports water all the way from the Colorado River. They even get a bit of water from underground wells. And Phoenix doesn't want to waste a drop, so they're smart about recycling, reusing treated water to keep parks green, and even recharging their groundwater. Since Phoenix is all about sunny skies nearly every day of the year, it's normal that people can get a little moody when it actually rains. But here's the thing. Phoenix always gets a surprise up its sleeve, even when it comes to bad weather. When it rains in the deserts, locals get treated to this unique earthy smell. It's thanks to the creosote bush, a desert plant that releases an amazing fragrance when the rain hits it. People describe it as the smell of rain, and honestly, it's one of those fresh, clean scents that makes you forget you're in the desert for a second. And if you've never stopped to think about why Phoenix is called Phoenix, well, it's based on that famous legend of the bird that rises from the ashes. Now, after knowing all the special things about this city and its unique ability to turn challenges into advantages, we can say the name couldn't have been better chosen.
Marriage is not only about happiness, mutual support, love, and friendship. Marriage is also about trials, crises, and storms. And this Swedish couple survived several storms during their honeymoon. Literally. Not screams, insults, and drama, but real hurricanes, fires, earthquakes, and other natural disasters. This is a really cinematic love story. Newlyweds against nature. Meet Erica and Stefan. They met in Stockholm while working on a joint project, parted, but started chatting with each other on social networks. Their long-distance communication lasted for several years before Stefan decided to ask the woman out on a date. And it's worth paying tribute. It wasn't a typical date in a restaurant or in a park. Stefan suggested that Erica fly with him to go diving in Egypt. They realized that they both loved to travel and finally fell in love with each other. After a fabulous wedding and the birth of a beautiful daughter, the couple decided to go on a 4-month honeymoon. The tour was impressive. From Sweden to Indonesia, then to Australia, New Zealand, Japan, and China. They didn't expect that the trip would turn out to be a real adventure where safety was not guaranteed. At first, they got stuck at Munich airport. All flights were delayed because of a severe thunderstorm. In Bali, Indonesia, they went to a high mountain with their little daughter. A strong wind began to blow at the top. It tore off the roof of the tourist bus where our heroes were sitting. Fortunately, no one was injured, and there were no other problems. But at that moment, it was just a teaser of the coming disasters. The couple arrived in Australia, where a wildfire first started near the city of Perth. Stefan and Erica didn't want to cough up thick smoke, so they quickly left for the city of Cairns. It was during that period when a ferocious cyclone began there. The storm was so strong that the Australian Red Cross Service provided shelter for 2,500 people in the mall. And there, another problem began. Imagine 2,500 people in a big, hot room without electricity while a hurricane is raging around. Oh, and there were only 5 toilets in the entire building. How nervous do you think people were? Eric and Stefan recall that some guys started fighting because of stress. The tension was getting stronger, but fortunately, the mall guards kept the situation under control. Wildfires, hurricanes, it seems that something is missing. Oh yes, what about an earthquake? The couple faced 2 earthquakes during their honeymoon, one of which happened in Japan in 2011. They went through all this together with their little daughter. Just imagine how their daughter was amazed by all these adventures. Such a trip strengthened their marriage. Of course, after natural disasters, any domestic quarrel would seem like a mere trifle. Erica admitted that in crisis situations, Stefan fully justified her trust and behaved as she had hoped. Oh, how sweet. What if we create tours for married couples who are planning to divorce? Survive the storm, fire, earthquake, and flood together, and then think again whether you should leave each other. Imagine that you've gone through several natural disasters in your entire life. Now the question is, are you lucky because you've survived, or are you an unlucky person because you've run into such troubles? It depends on how you feel about it. For example, there's a woman, Dana Weiland, who lives in California. She has survived several disasters throughout her life and continues to smile. And more recently, she's faced another disaster, wildfires in her home state. But let's take it in order. In 2005, Dana Weiland lived in New Orleans, and if anyone doesn't know, that year, Hurricane Katrina destroyed many houses in this and other cities. Dana's house was no exception. According to her, the lower floor of the house was completely flooded with water. Of course, she had to give up everything and evacuate. Dana and her family drove to Texas to a friend's place for about 20 hours. 1 month later, Hurricane Rita arrived there, and Dana and her family evacuated again. It looked as if nature was following her around, but our heroine was not one of the timid ones. Several years later, she faced another disaster, Snowmageddon. This was when a huge amount of wet, cold snow flooded cities and roads. Strong wind, blizzard, and endless snowfall. All traffic stopped. The lights turned off. The streets were empty. Dana sat for 11 days without electricity during this snow apocalypse. And after all these disasters, she got the exact opposite of snow. Wildfires in her hometown of Lake Arrowhead in San Bernardino County. Let's hope that this time, everything will be fine with her again, and she will meet any adversity with a smile on her face. Have you heard that lightning doesn't strike twice in the same place? Can it hit the same person twice? What if it strikes the same guy 7 times in a few hours? This is not a movie plot in a tragicomedy genre. This is the real story of Roy Sullivan, a man who got into the Guinness Book of Records for the number of lightning strikes survived. There are more than 8 million lightning strikes on Earth every day, which is about 100 strikes per second. But even so, the probability of getting struck is extremely low, 1 chance in 10 million. For Roy Sullivan, these chances were too high. For his strange record, people nicknamed him the Human Lightning Rod. For the first time, lightning struck him in 1942, when Roy was on a watchtower that didn't have a lightning rod. A bright flash of light and a powerful current discharge scarred the man, but didn't cause crucial damage to health. The next accident occurred in 1969, when lightning struck a tree near the road. The lightning passed through the tree to a car. Guess who was driving this vehicle? Roy lost control and almost drove off a cliff. Fortunately, he stayed alive again. Okay, the first time he was on the tower during a thunderstorm. The second time was on the road next to a tree, and as we know, lightning often strikes trees. This meant Roy was in a potential risk area every time. But the third time happened in his front yard. Lightning struck the transformer and caught his shoulder. The fourth time happened in 1972. Lightning struck Roy while he was working. From that moment on, the man began to suspect that this natural phenomenon was somehow attracted to his body. Maybe it was a curse, or maybe everything could be explained from a scientific point of view. A year later, lightning struck him for the 5th time. A thunderstorm started that day. Roy decided not to try his luck again and hid in his truck. And so, when the storm calmed down, Sullivan got out of the car and bam! Another lightning strike. There were 2 times left before the record. They occurred in 1976 and in 1977. Roy's bad luck spread to his wife. One day, lightning struck her too. It didn't hurt her, but scared a lot. So far, no one has broken Ray's record, but obviously, people haven't tried to do that. Okay, lightning, fires, snowstorms, hurricanes, and earthquakes. But how about tsunamis? Unfortunately, this is one of the most terrible and devastating disasters on the planet. If you survived it, you're definitely lucky. Zarul Fuadi from Indonesia survived these devastating water disasters twice. The first occurred in Indonesia in 2004. And the second happened a few years later during an earthquake in Japan. During the second time, Zarul was in the building on the third floor and felt a jolt. He was shocked and immediately remembered the tsunami he had experienced before. The tsunami hit the city, but our hero and his family survived. After this double trouble, he decided to move to his homeland, Indonesia. Despite the terrible events, Zarul looks at what happened calmly. Any catastrophe can happen to any person at any moment, but it doesn't mean you should live in fear forever. So, he focused on the bright side of life.